Okay, so what I want to do is I want to take the time to go through each one of the problems that you're assigned at the end of chapter one for this assignment number one, and hopefully answer any questions that you may have or give you the opportunity to, get specific about some items. So first of all, as we look at problem 1-1, in this particular problem, they want you to create the kinematic diagram for the mechanism that we see down here. This is the mechanism to open and close the door for a heat treating furnace, okay, as shown. And they want us to draw the kinematic diagram. So it says that the end of the handle should be a point of interest. So remember, a point of interest is going to be one of those X, Y's, or Z's. So in this case, because they're only identifying one point of interest, that is going to be point X that we're gonna be identifying. Okay. Now, as we look here, we want to kind of first of all identify what we believe is anything that is going to be stationary or the frame member. And as we look, you'll notice that this whole structure right here kind of sits on a floor. And the handle is going to be attached to, I'm going to call that the frame. Okay. And that point right there is not going to move. So the handle is going to pivot about this point. So it's going to go kind of, up and down or rotate around that. And as it rotates, for instance, if it rotates down, it's going to pivot up in the front here, okay, which is attached to this rod. And then this portion right here is the door that's going to go up, okay? As you push that handle down, the door is going to go up. Now, if we push that handle up, then that's gonna pivot the front part of that handle to go down, which is then going to push the door going down. And now the door, you can see, is constrained to only going up and down. So in this case, this is going to be one of those crank slider mechanisms. Okay. Now, I'm going to just ask, and when it's, or I'm just going to state one more thing. The end of the handle is supposed to be identified as a point of interest. So that point X would be out here. Okay. Because something that you might want to know is how far is the swing of that going to be? So that is it reasonable to, for instance, have somebody, push it up and down, or is it too far or too narrow or something like that? So as that as an overview, does that help? Does that help anybody who has maybe any other questions on this particular problem? Or we want to take it further and maybe set it up? Okay. Because we can also do that as well. So if there are no questions on 1-1, then I also want to let you know that this correspondingly, the diagram is problem 1-1. You would do this in AutoCAD as stated on our assignment. But then 126. So if we go to the end of this section here on page 29, 126 is the mobility calculation for problem 1.1. Okay. And this is where it's kind of like a 2-for-1 deal. So the first 10 points are going to be for the diagram. And then the second 5 points are going to be for that mobility equation. So make sure that you do both, and you can put these together on the same diagram. And then I'll see both. You'll get the points for that. Okay. The next problem that we have is going to be problem 1-3, which is down at the bottom on that same page in that same column. Here we have a folding chair commonly used in stadiums. And we see that diagram right here. They want us to draw the kinematic diagram for that. And then problem 28 is going to be the mobility equation. Okay. So here, as we look at our folding chair, what we want to do is, again, identify what the mechanisms are and then where the frame is. So you're going to notice that the cushioned part, well, I guess they're both cushioned, but this part of the seat is going to pivot up, okay? Or I'm going to go like this, pivot up. And then you're going to notice that you're going to have the seat part itself as one of the mechanisms. And then there are two rigid links here that are going to then pivot around this point, okay? So there are actually two attachments to the frame, this point and that point, okay? So even though there's two frame members, remember the frame is always just one. It's just that it's attaching in two places to a non-movable area, okay? And then you're going to have the seat itself out here, and then each one of the links that then are going to be attached with pins relative to one another. So as we look at this one, does anybody have any questions about how to get started on this one?
I had a question about the first one.
Oh, about back up here?
Yeah.
Okay. Okay.
As I'm setting up the drawing, I realize I'm starting to get a bit confused as to how to set up the wall for the sliding joint because I'm not sure which
Sure,
side I
sure,
need to
sure,
put it
sure.
on or
Yeah.
both.
Yep. Okay. So, so what I'll do is, I'll make a kind of I'm going to do a sketch. I'm not going to go to AutoCAD just yet, just for the sake of time. But this would be, problem 1.1. Okay. And, as we look at our diagram here, as we had stated earlier, you'll notice that this is the pivot point for this handle. So this is going to be my frame member, and then I'm going to draw the handle, and then I'm going to draw, I like to call this the connecting rod, and then I'm going to have the slider going up and down, which is going to represent that door. So I'm going to start by adding my frame member first, okay? And then I'm going to have my handle, kind of looking, I guess it's not at that extreme of an angle, something like this. Okay. Now at the end point here, these are my two pin connections, pin connection to the frame, and then this is going to be to the connecting rod. Now, one of the questions that was earlier was, when do I use triangles and when don't I? It's really going to be a clarity thing. In the case of this part, the handle itself is nice and straight, okay? And so technically you could represent it as a length, but what ends up happening, because we have two connections here and then it extends out further, it almost looks like it's two separate pieces if I keep it as just a single line, okay? So what I tend to do for elements like this is I like to add that little bit of thickness as so that it looks like, and you can kind of see that this is a continuous part. Does that make sense? Now, if it was
Yeah.
just a part like the next one we're going to do, which is the connecting rod, so I'm going to go down, and the connecting rod kind of went something. Again, this is, remember, in chapter 1 here, this is just, we're putting proportionals. Now, in this case, this connecting rod doesn't have any extension beyond the points that it's connected to. So as a rigid length for this connector, I would not add a triangle length here, okay? It's only because this has that extension past where the pin connections are that it adds a little bit of clarity for a continuous part, okay? So this one I would leave just as a line in between. And then as far as the door, now, even though the door has width, remember, we're just representing this as a slider because it has motion that is only going to be in a straight line, okay? And I think the question you were asking, Logan, is, okay, when I show it as this slider, which side do I put the vertical line showing it in relationship to what would be the frame, right? It doesn't
Mhm.
matter. That is up to you. Don't put it on both sides. That's all I'm going to say. Don't put it on both sides. But whether you put it on the left side or the right side does not make a difference. Okay. All that this does is it says it is constrained vertically motion wise. Okay. All right. So that would be kind of an overview of. Is that helpful?
Excellent. Yes, very much so. Thank you.
Okay. So now kind of going back to problem 1.3, are there any questions on this one? Does anybody have? Okay. All right. Then I'm going to turn the page. And the next one we have here is a toggle clamp. So this is similar, little bit different configuration than the ones that we did in class, but really the same operation again. So we have a handle here. This handle is going to pivot, and you'll notice that it pivots around this point right here. It has a connection to what would be then the clamping section, okay? Now, and again, you're going to notice that the configuration is slightly different here, but operation-wise, when I pull this up, the clamp is going to go up. When I push this down, the clamp is going to go down, okay? So As you look here, you want to make the diagram for this, all right? Now, in this case, they're not identifying that you need to do any special interest points. If you want to add them as the designer, as I've kind of said, during our lectures, you certainly may, okay? So something that might be of interest would be maybe the end of that handle or where the clamp is. So feel free to add those in if you want to, even if though it doesn't tell you to, but uh, but you can also leave them off too. It's not required for this problem. Totally up to you. Um, and then you're going to notice that number 34, which is also assigned to you, is going to be the mobility calculation for this clamp. So as you kind of look at this one, are there any questions at all? Okay.
Um, I sort of have a question on that one.
Okay.
Because it's not identical to the
Mm-mm.
one we did in class.
Nope. No.
Um,
By design.
yeah,
Yeah, no, that's okay.
I don't know. I can't
Did you
really.
want to see it set up? Should we do a little sketch and set it up?
I didn't make a CAD drawing because I was trying to
Yeah.
sketch it out before I
Of course, yes,
open
and
up CAD.
that's a good idea. Why don't we do a quick sketch and we'll kind of talk through this one. How does that sound?
Okay, yeah,
Okay.
I could show you the
So
drawing, but
so
let me.
as we look at this particular problem, you're going to notice that we've got our handle here, okay? And this is going to be a continuous point. You've heard me say this before, kind of like a little boomerang or a dog leg looking item, okay? This is attached to this right here, which we can see would then be bolted down. So this whole part right here is our frame. Okay, so there's two connections back to the frame that are not going to move, and we're going to be identifying those with those standard frame symbols. Then you're going to notice that there is a connection here, okay? And again, keep referring to this as like a connecting rod, okay? So that it's kind of exactly what it is, or a connecting, link or something like that. And then we have, if you would, our output over here, and this is where the clamp is, okay? Now, the most important part of this is really the clamping part. So it's going to be moving, relative to that frame member being connected to the connecting rod, and then we have our clamping spot here. Now, when we looked at a part similar to this in our lecture, I also kind of took into consideration, kind of what not really the shape of this, but the extent of that portion was. So whether you do it in, if you would, a triangle method, like they did in the book, or if you kind of include this and make it more of a polygon, that's totally up to you as the designer. Notice again, they don't tell you that they're interested in any special interest points, so you can take that whichever way you want. So what I'm going to do is I'm going to make another diagram here. Okay, so this is going to be problem 1.3. Okay, and this one, we are going to start with our frame down here. This is the one where the handle is going to be connected. Okay. Now, the handle you're going to notice connects here at the frame. That's the point that I'm just referring to here. Then kind of directly above, but a little bit to the leftish above it is going to be the connection to this connecting link. And then our handle is going to be one of those triangle looking. Okay. So I'm gonna put a pin connection right here. Remember, our pin connections are filled in. So it's gonna go up. And remember, we are just showing this to represent it. So we're not showing the thickness or the exact details of that handle, but this is how we'll represent it, okay? Then, now that I have the handle in place, then I'm going to go to this connecting link. So that connecting link is simply going to be a straight line. It has just its pin connections on either side. So we don't need to do a triangle, looking thing because it only is within those confines. Then the next part that we would do is going to be the clamp. Now the clamp is also connected to the frame, okay? So remember, we're not going to draw the frame itself, but we're just going to draw, we're not going to draw what the frame looks like, okay? We're just going to draw a connection to the frame, okay? Even though it looks like it's two separate things, It just means that it is connected to something that is not moving. And it can be two separate things, or in this case, it is the same, if you would, part that that then secures to the ground. Then what we're going to do is we're going to take that and we're going to make it whatever, this point out here would be like that clamp. So if you wanted to close this up and make it, for instance, a triangle down to the clamping area, that's totally fine. Okay. And that's what the book did. All right. But I, as the designer, if I was designing this, I'm always going to be interested in that throw, if you would, or that rotation of the handle. But I also want to make sure, for instance, that I am not, interfering with something else. I would make that front end look like that because that more closely, if you would, kind of represents the extents that you have to be aware of as it is going through its range of motion. Okay. Now, something we didn't do on the last one. So this is kind of just the basic of the diagram. And I know a question earlier was, what are the labels that we have to put on things? So why don't we finish this one up as long as we're here? So the labels we have to put on are the numbers for each one of the links, okay? So the number for each one of the links is going to have its number and a circle around it, and those have to be on all of our diagrams. So now we're going to put number 1 by the frame member. Whether you put it here or here does not matter, but do not put number 1 on twice, only once, okay? Kind of like on drawings. We only put the dimensions on one place. Then what we do is, now again, my way of doing it is if there's an input like a handle that is going to actuate the rest of the mechanism, then I like to use that as my first or my next number link. So this would be a number 2. The connecting rod would be number 3. And then I like to think of my clamp in this case as the output. Okay. So input to output. Now, do you have to do it in that order? These numbers can be arbitrary. Number 1 always has to be the frame, but those can be a little bit more arbitrary, but that's kind of the rationale that I use. Once we have our links in place, then we need to letter our joints. Our first joint is going to be the one, if you would, connected here, A. Then I just go around in that same fashion, and I'll put D here, in that same fashion of kind of from input to output. Put C up here so it's not so crowded. Something like that. Okay. And then this would be a completed diagram with all the labels that are required for each one of the links as well as each one of the joints. Are there any questions on that?
One of the questions I had on my list was it okay to put labels inside the drawing? And I guess it is.
Oh,
Does
it is,
matter
yes.
which
So
labels?
if you have like these triangle-y things, yes, you can put the labels inside or outside, whatever seems to fit best. Yeah. Absolutely.
Okay. Could you also put the labels in, for example, the square for the sliding joint? Sliding thing?
Usually not. So like you're talking up here, like would you, like for this one, this would be number 1, 2, 3. If it fits, all right, but typically this is going to be a little bit smaller. So I would probably put the 4 out here.
Okay.
Yeah. And then also, since we're kind of looking back at this one, if this is my joint A, B, C might fit there, okay? But again, it just depends on, how big or small your diagram is, especially in CAD, because you'll be doing these in CAD. Don't forget when you have a slider, it's going to be the connection, the pin connection here, but there's also going to be the connection, the connection between in this case, the vertical constraint for the motion and the slider. So it's an extra joint that we have in there. So don't forget that one. Okay.
Hey Kelly,
Yeah.
for that problem with the slider,
Yeah.
do you want like a leader line in AutoCAD pointing to the slider, or is it
No.
just fine?
No.
Okay.
Nope, you don't. Yeah, that's a good question. Remember, these are for layout purposes, and we're practicing this, and we're going to be taking this next, the next module that we look at is we're going to be then moving these around. So we really just want to have the labels on there so that when we want to see, for instance, the displacement of link number 4, we can see it in both places. Additionally, we're going to be then taking it a step further than that, and we're going to be looking at velocities later on. And then we're going to be maybe saying V4 or VC or something like that, looking at the velocity of any point or link that we have. Does that make sense? So we just want to keep the labels so that we can see them. But again, this isn't anything you would release to, for instance, production. This is going to be for layout and design purposes only. So no leader lines are necessary. Other questions? This is good. This is good. Okay. All
Is
right.
there a specific direction that triangles need to point?
Nope. Nope.
I noticed that
Like if I
So,
put it
okay.
on the top, could you put it on the bottom here? Sure. I try to look at where do I have information already. So in this case, I kind of drew my frame so that the bottom, the anchor was down. So then I had room on the top to finish my triangle. If this was up, I would put my triangle probably down. Does that make sense?
Mhm.
Okay. Other questions? Okay.
I know it doesn't
Oh, yeah.
really relate to the clamp where we're at, but like it had like a sliding mechanism to adjust the head for the clamp or
Oh,
the
yeah. Do you have
and then
to,
I was
yeah,
like,
you don't have to worry about that.
yeah, I was like trying to figure out how to draw that.
No. That would be one of those higher order joints, okay? And in this case, I mean, really having the adjustability, you would maybe play with that, the extent of that on your design process as well, once you start looking at, if you would, displacements. But at this point, when we're just drawing the diagram, we're just gonna like assume that that's just rigid, yeah, and not moving.
Okay,
Okay.
thank you.
All right. Okay, good. Good. The next problem here that we have is problem 110. And this is that child's digging toy. And I did briefly talk about this one, I think, the other day when we were talking about it, saying that we have one of these links there's a handle, goes straight up, but then it's also goes out to here. So it being a triangle is kind of hard to do. So I said you could do something, something more that looks like that, would, I think, be a fair representation of that. Besides that, okay, are there any questions on this particular one? And usually this is the one that you're like, this one's a little bit different. And I'm happy to set this one up if we need help with that. Any requests for that?
Yeah,
Yeah,
can we
that's
Okay.
set?
Yeah.
well,
Okay.
you go, Steve.
Oh, I was just gonna say, yeah, if we could set that one up.
Yeah, absolutely. And then we'll also do for this one, this is the one that does not have a mobility of 1. It's a different number. Okay. And so it is a little bit different. So I will go over here and scooch this up. So this is problem 110. Okay. And where we're going to start, I'm going to kind of zoom in here a little bit. Okay. And I'm going to get rid of my little sketch here. Is you're going to notice that this whole part right here with the seat that the person would sit on, this is all attached to the ground. So this is the frame. And you'll notice that really the one connection to the frame is going to be that first handled kind of T part that we see here. So we're just going to represent that. We're not going to draw the chair at all. We're just going to represent that as a frame item. Okay, just like that. So that's that bottom right-hand corner. And then to this, we're gonna add that T part. So here, what I'm gonna do is I am going to kind of draw this part going up like this. And then I'm gonna make it not super thick, but kind of come here. And then here-ish. Kind of make that shape that kind of showed earlier. Oops, that's a little further than I wanted it to go. And it doesn't have to be super perfect. Remember, this is a representation of. Now, as I look here, my connections to this part are going to be to the frame. Okay. And then they're also going to be to this part right here. There's a pin connection, and then out here to that shovel part, okay? So I'm going to put those in place. I'm going to have a pin connection right about here. And then on the very end, pin connection. Oops, sorry. You don't see what I'm seeing. Like that. This is a handle, if you would, up on the top here, okay? All right. Now, the next part that I'm going to add is the second handle, which is right here. So on that handle, there's going to be a pin connection to that part that I just created, and then another pin connection about a third of the way up, and then it has handle going up a little ways too. So here we have, if you would, going straight up, another pin connection right about here. All right. Now on this part, if I show this going directly up, here again, because it extends beyond the pin connection, it can look like it's two separate pieces. This is one of those places where adding that little bit of a triangle-y effect makes it more clear that it's a continuous piece. Does that make sense? Okay. So kind of trying to decide if I'm gonna, you know, make one a triangle or not, that would be something I would probably do for this one. Okay. So that's the second handle going up. Then as we look here, there's another piece that is just a horizontal pin connection, and then we're gonna have our shovel or our scooper, if you would. Okay. So our next one here is just gonna be horizontal line. This one can just be a horizontal line because its pin connections are on the endpoints of each one. And then the last one is going to be our scoop. Okay. So here, this goes directly up, this part of it. And then here, I'm going to make this kind of looking like a scoopish type of a thing. So not really a perfect triangle, but something like that. Okay. Now, as far as representation, I think I have everything represented that I need. So now I'm going to add my labels for the links and the joints. So my first link here is going to be number 1. That's going to be my frame. This is going to be link number 2. Link number 3, which is going to be that handle. Link number 4. And then link number 5. So 5 links in this case. 4 is our normal number, but this one there's an extra one. Okay. Now our joints. I'm going to start here at A. I'm going to call this one B, C, D, and E. And again, if you do it in CAD and you put the links, as long as they're close to where they're supposed to go, the links and the joint labels, that's okay. All right. As long as it kind of makes sense. Okay. And then the last part of this problem, once we have everything identified, our joints and our links, then we need to do the mobility equation. We know the mobility equation is F is equal to 3 times n minus 1 minus 2 times JP, or the primary joints, right? This would be multiplied. So here, the n is the number of links. Okay, so I have 1, 2, 3, 4, 5 links this time, right? 5, and that would be minus 1, minus 2 times the primary joints. So that's how many letters I have. 1, 2, 3, 4, 5 again, right? 2 times 5. Okay. So my F in this case is going to be equal to 4 times 3 is 12 minus 10. So my F this time is 2. All right. Now, as we had talked about when we talked about mobility, 1 is ideal, right? 1 is ideal. Anything above 1 just makes it a little bit harder to use, which is not a huge deal. That doesn't mean that it's not a good mechanism, but we always try to make things as easy as possible. And with a mobility of 1, that ends up being the best case scenario, meaning I only have to do one thing to get my mechanism to do what it's intended to do. In this case, I have to do two things. I've got a handle here and I've got a handle here. So those are my two inputs to get this so that I can, do the scooping and such that I need to do. And if you've ever done one of these, which most people have at some point, maybe at a playground or such, it does take a little bit of, figuring out, and then you can start working with it. But anyway, so is that helpful? Does that answer any questions about this problem?
Thank you.
Anything
Yes.
else on that one? You're welcome. Okay. All right. Then at the bottom of that same column on that page is number 111, which is assigned. But the problem or the picture is at the top of the next column. So this is a reciprocating saw, okay? And it says that they want us to draw the kinematic diagram, okay? And when we look at this, I'm going to zoom in here, okay? This is the mechanism. And it's this, if you would, circle, this link, and then the blade, okay? Now, the circle, we don't see it, represents the, little electric motor that is in there. And the circle is going to be on the center of that circle. And then there's like a flywheel that would be attached to it, if you would. Now, instead of drawing the circle as a link, we're going to represent it with simply a straight line going from the center of rotation of what would be the little electric motor in there to where it's going to attach to this like connecting link, okay? So we're not going to draw the circle. We're just going to draw, if you would, the radius to the connection. And then this center would be the frame member. And then the blade going back and forth would be a slider, okay? So you basically have a crank, right? Our input from the frame. We've got a connecting link, and then we're going to have a slider going back and forth here. So as we look at that, with that little bit of explanation as far as how to, show that circle, which is a little different than some of the things we've looked at. Any questions on this one? Okay.
Yeah, the radius part tripped me up, but it's just
But
even though it's a
explaining,
circle.
yeah, explaining it here, does that make sense?
Yeah,
How
that's
to
fine.
represent that? Yeah. So it's just going to be literally a line from the center to, that connecting link. Yep. So it's going to be this, and then a slider up top. Okay.
Yeah, that makes fun. That makes sense now.
Okay, good. And
So
then, are there anybody else have a question on that one?
I got one.
Yeah.
For the center of the circle, would that be the anchor point?
Yes, that's going to be
Or
your frame. Exactly. Yes. And that's where with hand tools, you have to use a little bit of, I don't want to say ingenuity, but a little bit of creativity. So in this case, yes, the whole thing is always going to move, right? It's not going to be bolted down to anything. But as we look at this mechanism, that center will not move, right? And that's really where the center of the, like I said, the motor is, where the rotational motion is coming from. So that would be your frame or your anchor point. Yes.
sweet, thank you.
You're welcome. Okay. Any other questions on 111 at the moment? Okay. Then I think the last problem we're going to look at is number 124, which I know we had a question on earlier as well. So 124 is oopsie, let me zoom out a little bit, is a sewing machine, and they want us to draw the kinematic diagram of this sewing machine. Okay, now if you're familiar with the operation of a sewing machine, you may or may not be, but at the center here, this rotates around and there's a flywheel that is attached to what would be the motor, if you would, that would be, if you would, in back of this or into the screen. Okay. So the center of this is going to be the center of rotation for the mechanism. Now, again, this is another circle item like a flywheel where we have the attachment or a pin connection to a connecting link here, okay? Which then is going to be actuating vertically our needle up and down. So this would be a slider in our case. This would be the connecting link. And then this radius here, just like the reciprocating saw, we're just going to draw it as a straight line from the center to the connection point of that connecting link. So we don't draw the circle at all. We're just going to draw literally a straight line from what would be the center, that would be the frame. And then it's just going to be then to another, sliding link going up and down this way. It's the very same mechanism as our reciprocating saw, but now it's just the slider is oriented vertically instead of horizontally. Okay. Now, I know there was a question on this particular problem. Did that help to clear that up, or do we want to see this one set up? Happy to do.
No, that cleared it up for me.
That cleared it up? Okay, sounds good. But does anybody want to see anything further on this particular mechanism at this point?
Yeah, I get it's this almost or basically the same
Mhm,
as
mhm.
the reciprocating saw, but this one has the pivot, or it has the radius, and instead of I just see like two arms instead of I see three arms instead of two arms. And I
Okay,
know it's two arms.
all right. Well, let's take a
But
peek.
like the slider, and then there's an arm coming off the slider,
Yep,
and then there's an
slider, and
arm
then there's going to be
attached
this
to the
link.
radius.
Yep,
Yeah, but then I just see three.
yep, 3, and then remember the frame member is number 4.
Oh,
So your
okay.
frame is technically number 1. Then you're going to have the link here, number 2. Number 3 is going to be the connecting link, and number 4 is going to be the slider.
Oh, okay. Now I get
Does
it.
that make
Yeah.
sense? Okay, yeah.
Yeah,
Don't
now
forget,
it's
yeah, the moving links are going to be 3, but remember there's the frame in there that's going to be that technically 4th link of the mechanism.
mm-hmm. Okay, thank you.
You're welcome. And then correspondingly, number 49 is going to be that calculation for the mobility. So each one of these is going to have a mobility of 1, except for that scooper one that we looked at just before. Okay. Now, any other questions on diagrams or mobility equations at this point? Okay. All right. So I think I took care of those questions. Now, there was a question on the case studies. Okay. Now, on page 29, this is the kind of the tail end of the problem section for chapter 1. We have a couple of case studies. So the first one here, 1-1, does a little explanation. There's a diagram down here. This is a mechanism that is going to be the feed device for filling ball bearings into a bearing. Okay. And they're kind of giving you a cross section here. And what we have is we have a motor that has an arm on it, a connecting link, and then this would be a slider going back and forth. Okay. Now these are 2 chutes that are going down. So these BBs, or these balls for the ball bearing, are going to move over here and drop down. And then as this comes back in the opposite direction, it's going to push, then it's going to move over and it's going to drop in here. So alternating, putting the ball bearings down into, each one of those grooves. Okay. So kind of knowing how this is going to, how it works in general, there are 6 questions for which you're going to answer. Okay. Now, when you answer these, make sure you answer them in full sentences. I'm not asking for an essay, but I want to make sure that you're answering the question here. And I like to think of it as, let's say you're writing an email to your boss and they have these questions about this mechanism. Try to, think of how you would explain this to somebody who you'd be working for. And you want to make sure that they get the information that they need. Okay. That's how I want you to answer each one of these. Does that make sense to everybody? And you might be asked to do that at times. Okay. Like send me an email on your analysis of, and I have these couple questions, and you want to make sure that you answer everything. So in that sense, that's how I want you to answer the questions here, like that much detail, if you would. Okay. Doesn't have to be crazy, but it has to answer the questions and be complete. Okay. So any questions about, at the moment, case study number 1? Okay.
No.
Then case study number 2, very similar. I'm going to turn the page because the diagram for case study number 2 is right here. So it's having you answer, I think it's 9 questions about the mechanism that we would see if you would in the inside of our toilets. Now, this is one way that a toilet might be set up. I encourage you to maybe look at one that you have access to and see if it compares to the mechanism that we see here. But in kind of going through this, what I want you to do is, again, the case study starts with the questions here at the bottom of page 29, okay, referring to that illustration on the following page. And then you're going to answer these questions. Like I said, let's say your boss would want you to, let you know how this mechanism works. Make sure that you're answering these questions in a way that you would present this to somebody that you would want to, if you would, impress or make sure that you're complete with your answers, because you don't want to go back and forth. You want to try to get everything answered right away. So make sure that you have the questions answered and in a way that, gives a good explanation. Okay. Any questions on that case study? So those are just going to be writing out. You don't have to draw any diagrams for the case studies because they're already kind of there. Okay. And by looking at what you see there, answer the question. So it's only written for the 2 case studies. No diagrams to create. Okay. All right. Any
feel good.
questions? Go ahead.
Oh, I feel pretty good about it. Thanks.
Okay. All right. Very good. So that's I think a more complete overview of the items that we have from assignment number 1. So what I'm going to do is at this time, I'm going to close or stop our recording.